Okay, this next unit is about electricity. First part, we're going to go just through some basics about electricity, including what causes it, which is charge. All matter is made of atoms, and here's a picture of a carbon atom that has lots of little parts to it. But then what causes all electricity is the fact that the particles inside the atom have charge. The protons in the center of the atom have the positive charge, and these are the electrons on the exterior of the atom. They have the negative charge. When there is an imbalance, or when the number of positives is not the same as the number of negatives, protons and electrons are unequal. When that's true, the atom will become charged. And when there are more than one charged object, like two things that are positively charged, they will repel one another. Like two positives or two negatives will repel. There's a force between them pushing one another apart. If they are opposite in charge, they attract one another. So because there are lots of different kinds of atoms, some atoms, their behavior is different because their electrons are different. For example, a lot of metals are conductors, and that is caused by the electrons in the metal being very loosely held by the metal, by the nucleus. Since the atom holds onto its electrons very loosely, current can pass easily from one atom to the next because the electrons can pass from one atom to the next. That is a property of conductors like metals. Insulators, on the other hand, are the opposite. They hold onto their electrons very tightly, and a lot of materials that you would think of as non-metals, like plastic and rubber and glass and wood, things like that, are not good conductors, so we call them insulators. A third class is called semiconductors. They have a sort of in-between ability to conduct electricity, and those are used in circuits, computer chips, LEDs, even some lasers. Alright, so two forms of electricity we think of are static and current electricity. Static, the word static means at rest, and electricity can be made to be at rest if there's just a buildup of charge. In other words, it's not moving through any conductor, it's just staying still inside of a insulator or conductor. And in this little picture right here, you can see this girl with her hand on this thing called a Van de Graaff generator. She is building up static charge because she's touching that, and the electricity is building up in her hair, and that makes her hair repel. Each strand of hair becomes positively charged, so they repel one another, and that's what you see as the result. Static charge can be caused by friction between a plastic rod and a cloth. The electrons from these two, they're both insulators, but the electrons have different attraction to the atom. These atoms hold on very tightly to the electrons. These atoms don't hold on as tightly because this is a better insulator. So what happens is when you rub the two together, the electrons from the cloth end up on the plastic rod. That's one form of electricity, static electricity. Current is flowing electricity. Here is a cartoon drawing of a simple circuit with a battery and a light bulb, and this is a wire, and the wire is made of metal, a conductor that has electrons in it, and those electrons can move through that wire because it's a conductor. So we call that the flow of the electrons, or the flow of that electric charge, we call current. The three main variables we look at in this unit are current, voltage, and resistance. So current, the first one we'll talk about here, the weird thing about it is the symbol in the equation we use is I. Even though current, the word starts with a C, we use I as the symbol. It's the flow of electrical charge, electrical energy. We measure current using an ammeter. This down here is a picture of an ammeter. It's simply a little tool that helps you determine the amount of current in a circuit. The unit of current is called the ampere. We usually shorten that to amps, and the abbreviation for that is capital A. There are two types of current we talk about, the alternating current. This up here is just a wall outlet like you would see at your house. This type of circuit, a circuit that has an outlet like this, uses alternating current. Alternating current, by definitions, says that the direction goes back and forth. The current does not move in only one direction, it moves back and forth, in and out. Usually we say that the electricity is going in and out of these holes. It doesn't just flow out of them, it flows in and out in a household circuit or household current. And 60 hertz is the frequency of that alternating current. It goes back and forth at a rate of 60 times per second. The electric charge actually moves back and forth. The other type of current is called direct, and direct current is the kind of current you see in a battery circuit. Any circuit that uses battery uses direct current. Current, it says, flows in only one direction. It doesn't go back and forth. And if you look at this picture, we have a battery. A battery always has a plus and a minus end. This is a wire connecting to a light bulb, and then a wire connecting to the other side of the battery. And this light bulb will turn on because there's current moving through these wires and through the battery. Well, the nature of that current is direct, meaning it only moves in one direction. It goes around the circuit like this. It always flows, always flows from the positive to the negative, just like this symbol shows. I, which is the current, is flowing this way. And that causes the light bulb to turn on. Light bulbs can also work in a circuit like this, obviously, because you can plug a lamp into this kind of outlet, which is alternating, and the light will turn on. So light bulbs can use either direct or alternating current. The second variable we use is called voltage. Symbol is V. That's easy to remember. Another phrase we use for voltage is called the potential difference. The potential difference between 2 points is called the voltage. So in a circuit, for example, this is a circuit that has a battery. This battery, or here's a little bit easier picture to see, this battery has a plus and minus end. We say the difference between those 2 points is the potential difference, also known as the voltage. For example, if we said this was a battery that had a 9-volt battery, or a battery that was 9 volts, then I could put in 9 volts on that side, on the 0 side, and 0 volts on this side. So the positive side would have 9 volts, the negative side would have 0 volts. The electric current will flow through these wires and through these light bulbs in this direction, positive to negative. And as it does that, the voltage drops every time it crosses one of these light bulbs. Every time it moves from one side of the light bulb to the other, the voltage drops. It starts at 9, it drops by 3, it drops by 3 more, it drops by 3 more. Since there are 3 light bulbs, each drop is 3, because 9 divided by 3 is 3. And when you're done dropping through the third one, you're down to 0 volts. The battery makes the voltage go up to 9. So battery increases voltage while light bulbs drop the voltage. So we call that a voltage drop when current drops, voltage drops when the current goes across a battery. The third electrical variable is resistance, which has the symbol in the equation R. And resistance is just like it sounds. It's how easily a current can flow through a material. So if a material cannot conduct very much electricity, we say it has a high resistance. Well, it turns out that even metals, which are good conductors, different metals have different amounts of current flow that can move through them because they have different resistance. It depends on the type of metal, it depends on the thickness of the metal, and depends on the length of the metal. The unit of resistance is the ohm. This is the symbol omega, and omega is what we might write, that symbol. So when that follows a number, that means the resistance. That's the unit. It's called ohms. So it says here copper is a better conductor than aluminum. A lot of wiring is made of aluminum. A lot of wiring is made of copper. But it turns out that copper is a better conductor, so it has lower resistance. Better than aluminum means copper has a lower resistance than aluminum. Even 2 copper wires can have a different resistance if they have different thickness or different length. A thicker wire has less resistance than a thin wire, or a longer wire has more than a shorter wire. So in this little cartoon diagram here, this is supposed to be a thinner wire moving through this circuit, and there will be higher resistance in that circuit, which causes the current to be low. Here there's a thicker wire, so there is less resistance, so the current will be higher. A lot of times it's very helpful to compare the flow of electricity to the flow of water through pipes. Electricity flows through conductors like metals, like wires, but water flows through pipes. And we can use it sort of as an analogy if we can compare behavior of water in a hose to the behavior of electricity flowing through a conductor. So the flow, if you look at these pictures here, the flow of the water in this hose, so here's just like a tank of water that has a pipe below it and water can flow, but if you look at the picture, I think this makes sense. This is a thicker pipe, a wider pipe. So a wider pipe allows more water to flow through. There's more more water flowing, more current. A thinner pipe has less water flowing through it. So the flow of the water in the hose is analogous to electric current. Up here the word amperage is used. That's really just a synonym for current. Here it says now voltage. Now suppose this water tank you could fill it up to much higher. The higher the water is in that tank, the more pressure is exerted on the water at the bottom where the opening is. Well, that's very analogous to voltage in an electrical circuit. So water pressure is determined by the height above, how much water is above. Well, that's very much analogous to voltage in a circuit. And if you look at these two pipes, these are two pipes with different diameters. This is a wide pipe, and this pipe has a crimp in it so that it's narrow. And water will flow much faster through this one than it will through that one, simply because, or more current can flow, I should say. More current can flow through this wider pipe than this one because it has a wider diameter. Well, in electricity, it's very similar. A wider wire or a thicker wire can allow more current to flow through since the resistance is less. So how easily the water moves through the hose is a measure of, or that's analogous to electrical resistance. Alright, so the last slide I'm going to show here, as soon as I clear these things, the last slide I want to show here is about Ohm's law. Ohm's law just simply shows the relationship between these three variables we just talked about: voltage, current, and resistance. And this little triangle shows the equation, helps you do the algebra in the equation, but the equation is simply voltage is current times resistance. The hardest part about this is remembering what these letters stand for. V, that's easy, voltage. And this symbol is V in the equation, and so is the unit. It starts with a V. So voltage is pretty easy to remember because everything's V. But when you get to current, it's trickier. In the equation, current is I. This one right here is the current. I is the symbol in the equation, even though current starts with a C. And what's even more confusing sometimes is that the unit for current starts with an A, amps. So those letters go together, C, A, and I. CIA. Sometimes my students remember that. Remember it by CIA. Those letters go together. And then the last one is resistance, which fortunately in the equation it starts with R. The unit does not begin with an R, but it's ohms. We say the word ohm and we write this symbol after the number. So this relationship V equals IR it shows how voltage, current, and resistance apply to one another in a circuit or even at a component like a light bulb or a battery.